Okay, boys, this is a proof that a perpendicular line drawn from a chord to the center of a circle bisects that chord. So the chord in this diagram on the left here is AB, a line drawn from 2 points on the circumference, a straight line inside a circle, a chord. And if we draw a line from the center of the circle at O, it will bisect, meaning it will cut in half the chord AB if it's drawn perpendicular. So if you consider the triangles AOM and OMB, which are the two triangles within the bigger triangle AOB, we're going to look at congruent triangles. That's why I've highlighted those words to prove this result. And in order to prove that the rule in the blue box above is true, you need to prove that A to M equals M to B, which will mean that that line O to M is a bisector, meaning it cuts it into equal parts, and if it's a perpendicular line, they will be equal. So if you consider OA and OB, what's special about them? Well, you can see that they are both the radii of a circle. That's the point there under point 2 for the proof. Now, I would like to use that point there before point 1 because I think that it's more vital to showing you how this proof comes about. So if you look at the red lines, you should be able to see that those two are equal. You can obviously see under point 1 that angle AMO is 90 degrees, which is also BMO. So far we've got a side and an angle, and OM, the perpendicular bisector of AB, is common. So if you think about the triangles OAM, it is congruent to triangle OBM because of the congruent rule, right hypotenuse and side. So that's one of the 4 proofs for congruent triangles. So our hypotenuse was OB, right, which was the lines of the radii, and AO. Our side was our common side, which is OM, 0.3. And finally, our right angle is obviously from point 1, angle AMO and BMO. So therefore, you can say that AM is equal to MB because they're matching sides of two congruent triangles we've proved. And therefore, it comes around that the perpendicular bisects the chord. So that's the proof for that. And like I said, you won't necessarily be asked to prove it, though it's good to understand how we get this rule.